So yesterday we had just started looking at the alternate all the various different kinds of angles, specifically quadrilaterals. We looked at the properties of four-sided shapes, right? So we started with triangles in topic one. And there was a couple other things there. There was trig, there was Pythagoras, but we started with triangles. Then we moved our way to quadrilaterals, which are four-sided shapes, and also all these different angle properties with them. Where we're kind of finishing here is, well, what happens if I were to give you a non-four-sided shape, something with more sides? There's different properties with those as well. So this entire unit is all about just the different properties of different shapes. Starts with 3, goes to 4, then it goes into things that apply to any shape at all. So that's kind of where we're going to head out to. So our plan for this topic is we're going to finish it up today. Tomorrow, you'll be given time to work on it in your assignment and stuff. On Monday, I won't be here, but there will be a recording available. And there will be a sub as well. The words. Oh, yes, there'll be a concept check on that day for this topic. There will also be a couple of stats questions in there, just as an FYI, just so I kind of have something, but there is a plan to get that information from you from other avenues as well. So it will be a stats and a geometric properties concept check. And then on Tuesday, we're going to start with our new unit, which will be unit 6. So that's just kind of the plan as an FYI. Okay, so we're going to, does anyone have any questions at all from like 5.2 about any of these questions before we keep going? You're in none. We're going to head over to page 203. We're on the 200s now. Just going to get to page 203. I'll give you a second for that. Okay, so we're going to start with this. And so we're now looking at regular polygons. So basically, a polygon is the fancy word we use for a closed figure formed by forming 3 or more line segments at their endpoints. It's a shape. A polygon is a shape, okay? Is really what it's kind of come down to. So all those segments must lie on a plane. Again, we'll talk about all this. They're classified according to the number of sides. So this is a polygon's just a shape. It's really what it is, right? Oops. You know a lot of these. You probably all know. You should all know what a triangle is. You know a quadrilateral, squares, rectangles, etc. Trapezoids. You've probably seen pentagons a lot in specifically like movies, and you probably are familiar with hexagons and octagons, right? So those are usually the most common shapes. Those are going to really only be the ones you're kind of going to need to know. At this point, I'm pretty sure you guys are good on these. These 3, pentagon, hexagon, octagon, those are ones you're just going to kind of have to know, because they might ask you like, hey, if you have a hexagon that has this, find, some answer. That's it. If they ask you about, well, what if you have this thing? They're not going to expect you to know this. They will say it's a 12-sided shape. So they'll give that to you. But these 3 are ones you're just going to need to know that, okay, octagon, octopus, 8 arms, 8 sides. Hexagon, 6 sides. Pentagon, 5 sides. Those are the 3 really important ones. So what's the difference between a polygon and a regular polygon? Well, if all the sides are equal and all the angles are equal, it's called a regular polygon. So all the side lengths are equal and all the angles are equal. So just to give you an idea here, if I'm drawing a hexagon, 5-sided, let's do that, and that, this has 5 sides, 1, 2, 3, there's 4 there, and there's 5. This is a hexagon, right? But it's not a regular, sorry, this is a pentagon, but it's not a regular pentagon. A regular pentagon would be something like that, just neater. Yeah, so the difference here is a regular one has the same angle, same sides. And that's where a lot of these properties start to emerge. If you're given a weird shape like this, it's not going to be about this information, or at least it shouldn't be. So regular polygon, the sides and the angles are equal. So how can we actually do some math out of this? Well, a lot of the questions we're going to be asked are about interior and exterior angles. I might have jumped up ahead a little bit too much than I wanted. Oh, right. Okay. No, perfect. So if I'm asking you like what the interior angles are, so we're going to be learning 2 things today. We're going to be learning about interior angles and exterior. I got something which I'll hand out a little bit later about that. Yeah, no, okay. So we have interior angles and we have exterior angles. So the interior angles here, where's my stuff? So the interior angles here are these things, right? It's the inside ones. So it wants us to know, like, hey, what's all this information here? So let's start kind of figuring this out here. So what we have here is we have a hexagon, right? This has 6 sides, as we can see. And it's a regular one. We see that because all of these outside lines are the exact same distance, which means all the angles in each of these triangles would be identical. So what we have here is we have 6 triangles joined with a center point. So here's what we know. We know that a triangle has 180 degrees, right? Triangle has 180 degrees. How many triangles do we see here? 6. So if we want to know how many total angles there are in here, if we have 6 triangles, it's just 180 degrees times 6. Well, we have a total of 1,080 degrees to work with. So that's what we know. And all of this, all the inside stuff here is 1,080 degrees. This also includes all these angles here in the center. So what I've made here is a circle, right? How many degrees are in a circle? 360. 360, right? So if I know I have 10,080 degrees and I have 360 degrees, I know that I have 720 degrees left for all of these things here. And so sorry, I gave you the wrong information earlier. We want to find these is what we want to do. So when I say the interior angles, I mean these things. Yeah. And you're going to notice here, I'm just going to zoom in for a second. When I say the interior angles, I mean the interior angle here. Pretend that these triangles don't exist. If I make this same polygon here, the interior angle is this green line here, right? There just so happens to be a triangle that kind of bisects that. But that doesn't matter. Like usually you're going to be given blank shapes. You have to draw the triangles yourself. So the interior angles are of the actual polygon, not the triangle. It's that green part there. So that's what we're trying to find. So logically, here's what I know. If I know there's 1080 degrees in all of this, I know this middle part here is 360 degrees. If I take that away, what am I left with? I'm left with just the degrees of the inside angles of this. All 6 of them. So I know these 6 need to add up to 720, right? So how can I figure out what one of these would be?
Would you just divide like 720 by 6?
Yeah, that's exactly it. So I have 720 degrees to work with here, and I have 6 of the identical angles. So yeah, I can just take 720 degrees and I can divide it by 6, which would give me 120 degrees. So the answer here is 120 degrees. Each one of these interior angles, this yellow part, is 120 degrees. That's what I found. Now, there's a couple ways you can do this. One's just by some logic here, but what if I give you a really weird shape? You know, what if I give you like a 100-sided shape? Oh God, that's hard. This works when it's a really small, nice, even shape like this. We were able to draw it. It makes a little bit more sense. But what happens if I gave you a theoretical shape, a 100-sided polygon? It's a regular polygon, but it has 100 sides. That's brutal. That's hard to work with. That's hard to even comprehend. So there's other ways of doing this. So what we end up using here, so we have an alternative. So here's your alternative solution. There's a little bit of notes here with this one. So, oops, you can use, I'll say the following formula to find the sum of interior angles in any regular polygon. So I'm going to give you a formula here. This will always work because, again, what if I give you a 12-sided shape, a 20-sided shape, a 1,000-sided shape? You can't really work it out that way. Our brains kind of melt down if we keep going bigger and bigger. So if I want to try and find the sum of the interior angles, so that's all of the interior angles added up, how can I do that? Well, the formula we use is this. Sum of the interior angles is equal to 180 degrees times n minus 2. You might be wondering, what's n? I will talk about that just shortly. So this is 180 degrees times n minus 2. Oh, did I not save that? Where is it? So this is a formula here that we can use. So, and if you're wondering, like, what is this n? Well, the n stands for, there it is. So the n is equal to the number of sides. Right. So if I were to give you, don't write this down, but if I were to give you a a 5-sided shape, well, it would be 180 degrees times 5 minus 2. Or rather, 180 degrees times 3. It'd be 540 degrees there, for example. Right, my math's right there. Yes. Right, and this makes sense. How many degrees are in a square? 360 degrees. 4 minus 2 is 2. 2 times 180, 360. But how many degrees are in a triangle? 180. 3 sides minus the 2, I get 1. 180 degrees times 1 gives you 180 degrees. So it's a rule that always works as long as it is a regular polygon. But this only gives you the sum of those angles, right? That only gives you the sum of it. What if I want to find just one of those angles? Well, what did we do up here? We found the sum of 720 degrees. How did we find just one of those angles?
By what we just did, by dividing into the numbers.
By divided it by 6, right? We divided it by how many interior angles there are. There's 6 interior angles up here, so I divided it by 6. So if I want to find the angle of one interior angle, this is not the sum. Now, if I want to find just one, take the sum of the interior angles, the thing that's right above this, divide it by the total number of interior angles. That shape above had 6 interior angles, right? So I divided it by 6. So we have 2 different options here. So if you want to find all the angles, you know how to do that. If you want to find one of these angles, you know how to do that. And if it asks you some weird thing, find 2 of them, well, you just have to take this and go one step beyond that. But that's how we end up doing that. So what we're going to do is I'm going to give you a second to find this sheet here. It's kind of a cheat sheet that I've made here. Sorry?
That's on the MLS.
It should be. I'm just going to double check. I am pretty positive it's on the LMS, but there will be a printed out version for those online. Let me just double check that. Okay, you have that perfect. Oops. It's not on the LMS, but let me throw it up there. Don't know why I didn't before. Yeah, there we go. It's on the LMS now. So this is a cheat sheet that I have here. And so right now we're just going to focus on the interior angles. We'll focus on the other stuff here shortly. But I just want to focus on these interior angles. So what you're going to notice here on this sheet is it's double-sided. There are a bunch of different shapes here. The most common shapes. 1, 2, 3, 4, 5, 6. I don't think I have the 11-sided one. 1, 2, 3, 4, 5, 6. Yeah, I did not put the 11-sided one on there because I couldn't find one. It's not in Microsoft Office, so I couldn't make it actually. But so it's just kind of a cheat sheet here is what we really have. And so we know that those interior angles again are these things here, right? Those interior lovely angles. Even if I give you a shape like this, where I know that, here's the middle, I can make a bunch of triangles out of them. The triangles themselves are not the interior angles. This red part are those interior angles. But it's a nice way to kind of think about it is that you can always make triangles out of a shape. Assuming it's a regular one, you can always make triangles, and those triangles will always be equal. Even in a triangle, you can make more triangles. So turning stuff into triangles has kind of been our friend now for the last 4 months, and it's still our friend here to find certain things. But the key thing I want to stress here is that you are not, when you're finding the interior angle, you are not finding the angle of the triangles. You are finding literally like the interior angle. So there is a difference there. So if you're to calculate these interior angles, so again, this is our formula up here, right? Well, we know that in a triangle, they add up to 180 degrees. We know in a quadrilateral, a rectangle, a square, they add up to 360 degrees. So what about in a pentagon? Well, in a pentagon, it's 180 degrees times, what's 5 minus 3? It's like 5 minus 2 is 3. 180 times 3 gives you 540. We know from earlier in a hexagon, it's 720 degrees, right? That was the question we just did earlier. What about in a heptagon? Well, it's 180 times n, which is 7 sides. 7 minus 2 is 5. That would give you 900. Do you see a pattern that's starting to emerge here?
It just keeps going up by 180 degrees.
Yeah, just keeps going up by 180 degrees for every side you add. Absolutely. That's literally the pattern. That's what's happening here. Every side you add, if we assume it's a regular polygon, it's going to be added to 180 degrees. And they'll always be equal as well. So all you do is you just keep adding and adding and adding. 1.
Twice.
Yeah, there we go. Then it's 1440. Seems right. And then this one does not go up by 180 because it goes from 10 to 12, right? This would jump up 360. Right, so those interior angles there makes sense. And again, in a regular polygon, I can always take a shape. If I take this one here, this looks like a septagon. From the center, you can always break those into nice even triangles. So here's my question for you. So if you're looking on this one here, this heptagon, that's that 6-sided figure here. That's one we just worked with, right? Oh. We know that in this, there are 720 degrees, right? And we know that each of these interior angles, these red lines, are 120. That was what we just found. My question for you is, what about, I'll use green to show it, this angle? How could I figure out that angle now? Now I actually want to know the angle of this triangle.
Would you minus 90?
Wouldn't minus 90, but I like the way you're thinking with it. So these are all It wouldn't be 45. So keep in mind, these are regular polygons. All the angles and sides are the same. So all these triangles are identical. If I know this red one here is 120, well, this is just half of that then, right?
Oh, yeah.
Because it's split directly, and I know it's not a very neat drawing, but it's split directly in half. So it would actually be 60 degrees.
Okay.
So that's how information, we can use that information now to always find all the angles now in a shape. We now have all the tools to find every single angle and every single shape, assuming it's we can break it down into triangles. Even if it's not a right angle triangle, we can now do it. And even if we do need a right angle triangle, well, you can always make one too. So we have a lot of creative options now with just simple shapes to be able to work around with. So we're gonna head back to our this one. We're gonna head back to page 205 on our document here. Where's my stuff here?
So is those other ones that we're talking about, like the 60-degree ones, are those the central angle? Or what's the central?
Well, we'll come in the central angle in a bit. I do have that planned for later today.
Oh.
Yeah, but good question. Yeah, so you're right. There's two things. You're probably looking at this. Oh, well, we also got a central angle. We'll talk about that one here shortly.
Oh, okay.
Yeah. So that's going to happen shortly. So what's happening just for the next little bit here? What page are we on? We're on 205. I'm just going to give you guys a little bit of time here to try out question 1, 2, and 3. Yes. So I'll give you like, I don't know, like 5 or 6 minutes here. Try out question 1, 2, 3. It's all interior angles.